Finding the x and y intercepts of a line involves finding these 2 points. Now, I don't know if these 2 points are the x and y intercept of this line, but I'm drawing them for a purpose. This in general is the y-intercept, the place where it crosses the y-axis. Whenever you cross the y-axis, x is always 0. This would be the x-intercept of a line. Whenever you cross the x-axis, the y value is always 0. So we can use these two facts to find the x and y-intercept. If I want the x-intercept, just set y to 0 and solve for x. So to find the x-intercept, we'll set y to 0. 5x minus 2 times 0 equals 3. That goes away. So 5x equals 3. And x is 3/5. So the x-intercept is 3/5, or as a coordinate, 3/5, comma 0. To find the y-intercept, just like we say up here, the y-intercept set x equal to 0. So 5 times 0 minus 2y equals 3. That goes away. Negative 2y equals 3. Y equals negative 3/2. Or, again as a coordinate, 0, comma, negative 3/2. These are two separate problems where we have to find the vertex of an equation. This equation is for an absolute value, while this will be for a quadratic or a parabola. I'll show you two ways to go about doing them, one using the formula and one using the calculator. For both of them, it's pretty much the same. We have this equation for the absolute value, y equals a times the absolute value of x minus h plus k, and the vertex is going to be hk. And so when I look at this and see that it's x minus 5 plus 4, so if I kind of write this right below, and let me erase the hk, I'll put the hk over here, and let me write this equation below, y equals 3/5 x minus 5 plus 4. You see a is 3/5, but that doesn't factor in the vertex at all. So h is going to be 5, not negative 5, because notice in the formula it's x minus h, so this is x minus 5, so h is 5, and k is 4. So the vertex here is going to be 5, 4. The parabola works in about the same way. It's y equals a times x minus h squared plus k, and again the vertex is hk, and so when I write this equation, I get y equals x plus 2 squared minus 6. And so a is 1, but again, a really doesn't matter here because all we want is the vertex. And so, again, watch the signs carefully. The formula is x minus h. This is x plus 2, so h had to be negative 2. And this is minus 6, so k is negative 6. So the vertex here would be negative 2, negative 6. Now we can find both of these on the calculator. By using the graph screen. So if I just go to y equals and then type in the equation, so 3/5, remember for absolute value it's math, number, x minus 5 plus 4, and then look at the graph. I always hit zoom 6 when I do a graph, just in case I've changed the window at all. It takes it back to where he was instead of hitting graph. So if we just count 1, 2, 3, 4, 5, and up 4, it seems appropriate. We can actually find that point because that point is a minimum. And so on the calculator, if I go second and then trace, so that's the calc menu, and choose minimum, and left bound just means any point that's to the left of that one. So usually I try to get relatively close, but it doesn't really matter as long as it's to the left. Hit enter. Right bound means to the right of that point. So as long as I'm anywhere to the right, and hit enter. And notice these two arrows pop up. The idea is that your minimum point should be between those two arrows, which clearly it is. And so then the guess, just put it somewhere close and hit enter. And minimum, if you notice, we get these weird decimals, and this happens every once in a while on the 84. But if you notice, it's 4.99999 and 4.0000. I don't know why it does that instead of just rounding off, or not really rounding, but getting rid of those decimals. But basically, if you get a situation like that, it's 5.4. You just have to realize that that's what the calculator does sometimes. I can do the same thing with the parabola. Let's go back to y equals. And now just change the equation. And again, we had a vertex of -2, -6, which looks appropriate, but here again I want to find the minimum value. So second trace, number 3 for the minimum. Left bound, some point to the left of the minimum. Right bound, some point to the right of the minimum. Again, notice our minimum is in between those arrows. For the guess, just put it close and hit enter. And this time we get the exact values. We don't even have to mess around. -2, -6. So there's a way to find the vertex off the calculator. You can either use it directly or use it to check your answer.